Okay, so we are going to get to the next part of the bootcamp, which is contract structure. Structure of how to define, how to work on a Solidity contract. So first, we're going to talk about state and local variables. So state variables are variables declared at the beginning of the contract and outside the scope of local variables declared in functions. So right here, we have an example. So we're going to take this example over to Remix, and then we can go a little bit deeper on this one. So in Remix, I created a Solidity file called contract structure.sol. Then we're gonna copy and paste this one in. Let's remove these part first. Okay, so let's start with a blank contract. So you have, remember our lessons, we have SPDX license identifier, GPL 3.0. It's also very equivalent to MIT, by the way. Then you have pragma solidity 0.4.0, bigger equal to 0.4.0, less than 0.9.0, right? Standard stuff, pragma solidity, declare a version of solidity once you want to use. The next one is you're going to use the keyword contract to declare a contract. And over here, I declare a contract name, simple storage. And Solidity is a curly braces language. So you use curly braces to basically encapsulate the logic of the contract. And nothing inside, if you have nothing inside a contract, it's still a valid contract. You can see that it's compilable. You can be compiled. It means it's a valid contract. Valid Solidity doesn't mean it's a good contract. Just means that the code is valid. Right. So now let's get to the other part, right? Let's go to the part that, let's take in this part. UN public store data. So this one basically means I just declare a state variable, right? A variable that's accessible across this contract, right? All the functions inside this contract will be able to access this data, this piece of data, this variable. There's a public here. So there's these two parts, which will be explained a bit further along the course, which is type and also visibility, right? We talk more about those. So this one, you're declaring a state variable. Then the next part, let's do this one. I have a function called update store data, and I take in new data, which is taking the input, and then it's a public function, means anyone can call it. Curly braces. That's just how the function is. How to write functions. Then you have UN formatted data equal to new data times 2, and store data will be equal to formatted data. In this case, formatted data is local variable, right? It's a variable that is inside these functions. It's only callable inside this function. It's used as an intermediary before you start interacting with state variables, at least for this case, right? So now, how do you know that if it's a local or state variable, right? Very kind of simple. One is you just kind of look at this. You know that this is a state variable. This is the local variable. The other one is compiler will not compile if you try to do the invalid stuff, right? Like for example, I have a function here called get formatted data, and it's public, and it's gonna return. I'll call this functions. It's gonna return unsigned integer to me. And what it's gonna return is gonna return formatted data over here. But then you see that it said there's an error. It's called declaration error, and it's undeclared identifier. Basically, because the formatted data is only locally inside these functions, so then you're not gonna be able to compile over here, right? So, but if I do the same but for different data, let's say for this one, functions get store data. Right, same thing, but then I return store data, which is a state variables. 100% no problem to compile, right? So I kind of compile, you remove it, compiles no issues, right? Can be compiled. So because state variable can always be referred by all the functions inside the contract. All right, so functions. So basically, functions I use to declare to perform calculations, change the value of variables, changing things, changing states, doing logics, right? Functions are where all your logics live. So then you use the keyword functions to declare this. So you can see something below. I given an example how a function is given, how a function is declared. So you can have something like contract, simple auctions, and you have functions called bid and then you have public payable, and this is the functions fully working. And you can also have helper functions, which can be defined outside of contract if everything is standalone. And the helper usually comes in the form of like a peer functions, and you will learn more about peer functions in coming up in the visibility sections. You have different kind of like different type of functions, and you can use this one to basically, for example, you put there's an input and multiply by 2, you return something, right? It's like think about those functions for you to manipulate data, for example. If you need to manipulate data the same way multiple times, you can wrap that into a functions and use that as a helper function to declare outside. So if I copy the whole part right here over to this one, right, it is compilable, right? It works. So then it's a valid solidity. Coming up next, you're gonna have function modifiers. So function modifier are declarations for function to create conditions for running the actions of that function. For example, in this contract purchase, I declare here, you have the address, which is to have declare a variable called seller, and it's an address type, and it's public. And there's a modifier here called modifier only seller. Require message sender to be seller, and only seller can call this. And you also have this underscore and semicolon right here. And you have function abort public view only seller, apply the modifier usage over here. So basically the modifier only seller, like in this way, basically is saying that you have a modifier name only seller, and then what it does is it require the person calling the function to be the seller. Only seller can call this, and it will always check these conditions before the code below. So for example, in this case, you have something like this. So you have functions abort public view only seller. So this modifier will be run before the logics inside the functions. All right. So that's how function modifier works. So next part is we're getting to events. Event is a feature for recording smart contract activities. Events is often used in building interactive UI for smart contracts. So just to let you for a note, event is not interactable by the contract itself. That basically means that contract doesn't see event. It only can emit them, right? So basically, if you, for example, I have an example right here. You have an event called highest bid increase. Address bidder uint amount event, right? So imagine you have contract simple auctions, you have function bid, and then there's a bunch of logic in here, and it like people like adding money into the bid, and every single time someone add money in, increasing their bid, that means the highest bid gets increased, right? So then you can emit an event saying the highest bid increase with the message sender and the message value. Basically it's like signal in some programming language or some frameworks. You would have like programming frameworks, you would have something like signals. So basically when something happened, like for example this piece of logic is ran, it will shoot out a signal for another piece of logic to run. This event works the same way. Basically let's say you are submitting your function is submitting a bid, but you don't know, as your UI, in your front end is your front end just interacts. Someone just send the transactions using your front end, and then you need to figure it out okay, when do I will show this action has been completed, right? So you would do something. You would be based on emit, right? Like if the event has been triggered, been emitted down, and you can use this one to show in the UI that your transactions has been confirmed, like 100% confirmed, because the event also get emitted. So usually the event would be emitted last, unless it's different kind of events, depending on the actions. So you want to essentially do your actions, then emit the final event, right? It happened, right? But for you to kind of confirm, like good, 100%, it did happen. Next, we're going to talk about errors. So errors used to inform the user why the action failed. An error has lower gas cost than returning strings. All right, so this is a note. So Previously, anyone who used Solidity before, like the older version, like before 0.8, I think less than 20, you would not have this custom error code. You would not have error, not enough funds, UN requested, UN available. You don't have this one. Very likely you would do something like require, and then you add a require, and then you add a error string to it. However, because you're storing a string, that means you're taking a lot of storage. That means there's a higher gas cost. But for error, it's a special keyword inside Solidity now, and then you can use it without incurring significant gas costs for you. So basically here you can have something like not enough funds for transfer, request, but only available, right? Basically it's like if you don't have enough money, so emit an error, right? So it will have error, not enough funds, and then emit two values come with the error, which is one is the requested amount and the other one is the available amount, right? So you have something like contract token, blah blah blah. You have function transfer, right? This is what you need. So transfer. You have a balance, so you check the balance of the person calling the function. Message sender is a global variable, and if the balance is less than the amount that the sender is asking to send, then you revert, right? It's like, oh, you don't have enough fund, just revert. The only thing with this error is you have to use the thing with this error keyword is you use it with the if. Before, you cannot use it with require. However, in a newer version of Solidity, you can use it with require, but you have to use this feature called via IR pipeline. We're not going to touch on via IR inside this bootcamp. It's like an advanced feature that you very specifically why you want to use that one. But for you, very likely just need to do an if statement. So if something doesn't satisfy, just revert. Okay, now we're getting to struct types. So struct is used to declare a type of objects. For example, you have an object that doesn't conform with the normal types like string, like integer, like boolean, those ones. Like for example, it's like an object with, for example, it's like, let's look at the example we have over here. We have contract ballot, and you're going to declare a struct called voter. This is a object representing the type of a voter. So you have, voter can have a weight. So how much weight the voter is. You have a boolean, which is like did the voter voted or not. You have an address delegate, essentially who the voter delegated to, and you have an integer, which is a vote. Essentially, think about like how many vote that the voter has voted. For example, if this voter has a lot of vote, that's one example of the struct that you can have. So basically, you use struct to declare a custom type. And you can use it for like an object, something like this.